Okay. In previous math courses, last year, specifically, in both 10-3 and in 10 Common, we were converting within and between the SI, or metric system, and the imperial system of measurement. It's important that we be able to do this simply because in our society, we deal with both types of measurements. Any of you ever worked on a vehicle or have done any building whatsoever know that a vehicle itself can come in both imperial and metric measurements, and they're not the same. If you hand somebody a metric ratchet on something that's an imperial nut or bolt that you have to maneuver, it's not going to work as well as a metric to metric. So there's three ways that we can convert. We can use the SI chart as a number line. We can use proportional reasoning, and we can use unit analysis. So we're going to review these methods, and we'll talk briefly about accuracy and precision. We're not going to spend a lot of time, but we are touch on it. So if we look at the following chart, these are your symbols and your prefixes for the metric system of measurement. In the middle, we have our base unit, the meter, the gram, or the liter, depending if we're measuring distance, mass, or volume. Okay? Then if we move down this way, we've got deci, centi, milli, and then we have micro and nano. Micro and nano I wouldn't expect you to memorize, but you should be able to comfortably move from a meter to a millimeter without me having to remind you how many steps there are in between. The same thing going from a meter to a kilometer, and then we have a mega and a giga. Megas and gigas might be a little bit easier to remember if we think about the fact that a megabyte and a gigabyte have the same relationship. A megabyte is 1,000 kilobytes, and a gigabyte would be 1,000 of those megabytes. And a terabyte, which is the new platform for, or the new storage system that a lot of computers or the externals are talking about, that would be 1,000 times a giga. In terms of what these numbers, this is in relation to a meter. So a giga is equivalent to 1 billion meters. A mega is 1 million meters. Kilo, 1,000, 110. And then when we go this way, what we get is a decimeter is 1/10 of a meter. A centi means 100th, 1,000th. This would be 100,000, and then this would be, or sorry, not 100,000, 1 millionth and 1 billionth of a meter. So if we're using a metric number line, as we move through the number line, it's a power of 10. As I go upwards, I multiply by powers of 10. So as I move this way, I would be multiplying by powers of 10. As I moved this way, I would be dividing by powers of 10. The next chart that we have is conversions between imperial and the metric system, or even imperial and imperial. So in the imperial system, basically these are the most standard type measurements that we deal with. Inches, yards, feet, and miles. 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile, or 1,760 yards in the same mile. And then these two charts are conversions from imperial to metric or metric to imperial. So 1 inch is about 2.5 centimeters. 1 mile is about 1.6, or even if you wanted to round it down, 1.5 kilometers. A centimeter is about a little less than ½ an inch. A meter is about 3.3, or a little bit more than 3 feet. A kilometer is, again, just about ½ a mile. So I can round some of these if I was doing some quick estimations in my head, but if I wanted precise calculations, I would have to use these conversions. So if we use a metric number line to convert within the SI system, the thing that we need to remember, and this is why the SI system was invented, is because the movement within it is all powers of 10. So it's a lot easier to make my conversions within the SI system compared to the metric system. So for example, if I want to go from kilometers to centimeters, if I was to take that line on the previous page, so I'm going from kilometers to centimeters, I have to move 1, 2, 3, 4, 5 spaces. So I'm, in a sense, I'm dividing, or I'm moving to the left. The way that we would mark that is we would make it a -5. That would be the same as dividing by my power of 10, is to let my exponent be a -5. Because to divide by 10 to the power of 5, which would be 100,000, is the same as multiplying by the reciprocal. So if you look at how they're showing to convert from kilometers to centimeters, oh, sorry, it's going from centimeters to kilometers is this one. Going from kilometers to centimeters is multiplying. I think I have that backwards on the chart, don't I? Yep. I have to change my arrows. When we go up, we divide, and when we come down, we multiply. So if I have 18 kilometers, that would be times 10, times 10, times 10, or times 1,000. I would have 18,000 meters. So I should have more meters than kilometers, right? So it says use the metric unit number line to complete the following. 1 meter to centimeter. So if you flip back on the previous page and you look at the number line, if I'm moving from meters to centimeters, how many spots am I moving? 2. And I'm moving to the right, so that's multiplying by the power of 2. So if I take my 1 and I multiply it by 10 to the power of 2, I would get 100 centimeters. So if I look at the next example, 2.3 liters to milliliters, if you look on that number line, if I'm moving from liters, which is that middle column, to milliliters, how many places? 3. And it's going to the right, so it would be a 10 to the power of 3 that I would multiply by 2.3. 10 to the power of 3 is how much? No, other way. You're dividing. 1,000. So if I take 2.3 and I multiply it by 1,000, what would I get? 2,300. So 2.3 liters would be the same as 2,300 milliliters. Question C, you're going from centimeters back to meters. So I'm moving 2 spots again, but I'm moving to the left. So it'd be 10 to the -2. And I would take that and multiply it by my 750.
So if we were to answer that question, do we just put 10 to the power of 2 or 750 times 10 to the power of 2?
750 times 10 to the power of -2. And then I would actually evaluate this out.
Okay.
So 750, 10 to the -2 would be 0.01. So this -2, in a sense, tells me how to move my decimal place. I move it 2 over, and I would get 7.5 meters. This 3 tells me to move it to the right 3 places, or to the right 2 places. So if I look at the last one, going from milligrams to kilograms, how many jumps do I have to make along the number line?
6.
6. So it'd be 72,350 times 10 to the -6. This -6 is going to tell me to move my decimal place over 6 times. So if I move it over 5 times, I end up being ahead of the 7. I need to move it one more time, which would give me a space of a 0. So 72,000 milligrams ends up being 0.07 of a kilogram. So what I'm going to give you to do right now is questions 1A and C and 2A and C for practice.